All right. So this video is for Friday the 18th. We are going to be describing transformations of specifically quadratic functions. We're doing reflections, stretches, and shrinks. Yesterday we did horizontal and vertical. Okay. Again, you're going to be using Desmos for this today to verify your work, but you want to be able to identify parts of the information given an actual equation without having to graph it if possible. Okay. So the information that we have is again similar to previous lessons because these ideas repeat for all different kinds of functions. But in this unit, we are only talking about quadratic functions. Okay, so reflections in the x-axis. If we start with f of x equals x squared, remember that's the parent. Right? Then to reflect or flip over the x-axis, we do a negative f of x. Okay, and that is equal to a negative x squared. Okay, because all you're doing is multiplying a negative times whatever f of x is. Okay, and because we are only manipulating the parent, there's no other shifts right now. Okay, this is what you get. And what it does is it flips from being up like a U, and this one is f of x, to down like an N. Okay. And what you're going to be looking for is you see how there's this negative out front in the final answer. So if you have a negative out front, it is below the x-axis. It's pointing down. Okay. So this negative value here, okay, indicates that there would be a reflection in the x-axis. I can also have a reflection in the y-axis. So again, it would flip over the y-axis. Oh, this was negative x, sorry. But because of symmetry, okay, if this was f of x, whenever this flips over the y-axis, okay, it actually just like flips on top of itself. Because if it's centered here and it reflects, the left side goes to the right. Okay, it's easier when it's over here, when it's also been shifted to the left or to the right, and then it flips, then you can see it a little bit easier. But when it's at 0, 0, it just looks like it's right on top of itself. Okay, and the rule for that is if you start with f of x equals x squared, your negative goes inside. Okay, here your negative was outside. And you get negative x squared, which then results in a positive. Okay, because a negative times a negative would make a positive. So in this case, it's its own reflection. And when we talk about these, we also do the vertical stretches and shrinks. Okay, so remember that you are a horizontal stretch or shrink. Okay, so if we start with f of x equals x squared, which is the parent, and we've done something to it where there's a value being multiplied by the x. Okay, so notice this a is inside of these parentheses. Okay, so if this is what happens, Then this is the same as notes we've written on the other page because it applies. So it's a stretch if A is between 0 and 1 horizontally. Make sure this is horizontally, okay? And it's a shrink when A is greater than 1. If you need to pause, but I have to adjust this. Okay? So then the vertical stretch or shrink, again, if we have f of x equals x squared, okay, which is the parent, and eventually we will compare these to two different graphs. Okay, but right now everything is based off the parent. Okay, it's a vertical. Oh wait, hold on. Let me finish writing the function. Sorry, I'm getting ahead of myself. Remember, vertical is a times f of x. So if you see ax squared, so notice up here the a was inside the parentheses. Here the a doesn't have parentheses. The squared is just on the x value. Okay. So if we are dealing with this, okay, then it's a vertical stretch when a is greater than 1, and it's a vertical shrink when a is between 0 and 1. So again, we've dealt with this with the absolute value functions and some linear functions in the previous lessons, and the rules are still the same. Okay, so we're going to describe the transformation of f of x. Okay, and I'm going to write these rules here because currently we're comparing it to the parent, and again in the future that'll change. So, and then it also tells you the graph. And again, you'll use Desmos for that right now. Okay. So A says if g of x equals a negative 1/2 x squared. Okay. So from the notes that we just wrote, okay, this is a value that's being multiplied by the x. Okay. So this is called A. And things you need to notice about A is if it's positive or negative, which is a reflection. Okay. And if it's greater than greater than 0. Whoa, it's really early while I'm recording this. Greater than 1 or between 0 and 1. Okay, so what we say is that because it's negative, okay, it's a reflection in the x-axis. And I wrote why it is because we're virtually here. So you need to remember why you're saying that. It's because it's negative that it's in the x-axis. Okay. But then remember that A is actually the 1/2. Okay. We don't talk about it in terms of the negative. It's really just the value that's there. Okay. So because it's 1/2, you can say that it's a vertical shrink by a factor of 1/2. Remember when we did the last lesson, verticals are whatever the value of A is, but horizontals are the inverse or the flip. Okay. And I have to say that it's vertical because there's no parentheses involved here. You're going to be horizontal when you have these parentheses involved. This one doesn't. The vertical does not. Okay? The next equation says g of x equals 2x, the quantity squared, plus 1. Okay, so think about what's happening. Now, this has more than just a multiplier here by the x. It has this plus 1, which is what we did yesterday. Okay? So things you need to notice is that this is working as a, and this is working as k. And again, we did this one yesterday. So if you missed class, you need to go back and watch it. So when we look at A is a 2, okay, and it's positive. So because it's positive, there's no reflection, okay? Because it's positive, again, there's no reflection. It's going to be a graph that goes up like a U, okay? This one was down like an N because it was negative. And because 2 is greater than 1, it's going to be what? Well, I go, ooh, wait, this is in parentheses. So I need to talk about this in terms of horizontal. So I'm going to look at horizontal. I'm going to say, ooh, A is 2. So my horizontal, A is 2. 2 is greater than 1. So that word I'm going to use is shrink. Okay, because 2 is greater than 1, we're using the word shrink for horizontal. Okay, now you have to remember this from the previous lessons. By a factor of 1/2. Because remember, it's not 2, it's 1 over 2. Okay, and they haven't just done that. They've also done a plus 2, okay, which means shifting 1 unit up, okay? Because a plus 1 will shift it up. And then you will have to graph it, and you'll probably use Desmos, okay? Again, we're starting from the parent because eventually we won't. If I have g of x equals a negative 3x squared, okay, think about what this negative 3x does to it. And pause it so you can think. Okay, so first I'd say it's negative, okay? And negative causes a reflection in the x-axis. Okay, and a is 3, right? Okay, there's no parentheses involved. It's just multiplied by the x. So this is going to be vertical because there's no parentheses. Parentheses, horizontal, no parentheses, vertical. So it's a vertical. Okay, stretch. And I get the word stretch because 3 is greater than 1 by a factor of 3. Okay, so remember, if values are inside, it has to do with horizontal actions, which means left, right, okay, when we're inside parentheses. If we're no parentheses or outside the parentheses, okay, it's going to have to do with vertical. And you can still have plus and minuses, which are up and down. Okay? If you want to, you can graph them first if you're struggling with the words. Okay? But remember that tutoring is on Wednesdays if you need one-on-one help. And we'll try to go over some more problems in class, but hopefully this will give you a good start.